Good morning, everyone. Today we are going to see from Reccsar. We are going to see about the online workshop on MongoDB Unleashed, Design, Develop, and Deploy. So Reccsar and ISPT, we are going to do that workshops. All of them, thanks for the participations. So hope you will be enjoying the sessions. So all of them will get a e-certificate after the completion of successful completion of the courses.
Hello.
Now we can start the sessions. Yes, sir. So now it's I think
So, hello all. Today we are going to see about MongoDB and like how data is sent to the modern applications. So, we'll be seeing the overall design, development part, and deployment part of MongoDB. So, every single second you spend online, like a photo, streaming a song, ordering food, or asking an AI a question, you are triggering an invisible wave of data across the globe. But as developers, we have to ask ourselves, where does all this data actually go? And how do modern applications manage it at lightning speed without any crash? So, welcome to MongoDB Unleashed. Today, we are taking you from the fundamentals of data principles all the way to building a modern real time applications. Others kindly mute your mic. Others kindly mute. Thank you. So, to understand how we store data, let's
Bluetooth
first,
போட்டுட்டியா?
excuse me, can you mute? Others kindly mute. Please do not unmute while the session is happening. So, to understand,
now you can unmute yourself, sir. Now you can unmute yourself. Now, sir, now you can unmute. You can unmute.
am I audible? Where did we leave? Am I audible right now, sir?
Yes.
Okay, fine. So, here, look at the screen right now. Whether it's social feeds like e-commerce stores updating their shopping carts, or IoT devices streaming continuous GPS updates, or an AI apps keeping track of your conversation history, software isn't just code. It's a constant sequence of data events. The central question every developer faces is simple: where does all of this data actually go? So let's test a dangerous idea. What if we kept all this data in our application's temporary memory? So this is an example of an app without database. Imagine you're building an app and you store your active users in a standard JavaScript array in memory. It feels fast and easy while coding, but what happens the moment your server restarts? It runs out of memory or crashes. Okay, 100% of your user data, active orders, um, and the state vanish into thin air instantly. Application RAM is volatile. It forgets everything when the process dies because RAM is temporary. We need a permanent, reliable storage system, a proper database. So we need a database, right? The primary purpose of a database is simple: durability, structure, and rapid data retrieval, even when server crash. But here is a real developer dilemma. Data doesn't always look like neat spreadsheets. So, do we force our application data into traditional relational SQL tables, or do we use a flexible document no SQL architecture? Let's look at the traditional SQL approach first to see where it excels and where it starts to friction. So this is the relational approach. For decades, the relational approach ruled the world. It organizes data into strict tables with fixed rows and columns. For example, you have a customer's table and an orders table connected by a foreign key like customer ID. Quick show of hands. How many of you have worked with SQL queries or joins before? SQL is incredibly reliable for structured financial ledgers. But what happens when our data isn't perfectly relational? Let's see what happens to relational tables when the application data starts getting complex. So when the data gets complex, look at how developers naturally think in code. A single user object containing an array of skills, nested addresses, and preference settings. In a traditional SQL database, you can't easily fit arrays or objects inside a single call. You are forced to chop that single entity into five separate tables like user skills, and addresses, preference, and whatever you need, and stitch them back together with complex joins. The document advantage is simple. Store the entity in the database exactly as it lives in your code as one clean self-contained object. But this brings us to a major shift in database evolution. No SQL. So let's enter the no SQL. No SQL stands for not only SQL. It wasn't created to destroy relational databases, but to handle high agility, massive, and modern object oriented code. While SQL enforces rigid schemas and costly joins, Document NoSQL gives you dynamic schemas, embed arrays, and high developer speed. NoSQL isn't just one database type, it's actually a family of four distinct architectures. The four NoSQL families. So, the NoSQL ecosystem consists of four main categories. Key value, which is used for ultra fast lookups like Redis. So, white column, it is used for high throughput analytics storage like Cassandra. Graph, it is used for ideal mapping explicit relationships and like social networks in Neo4j. So, for document storing, it is used for storing flexible hierarchical JSON style documents. Today, our entire focus is on king of document databases, which is MongoDB. So, what exactly makes MongoDB the leading document database in modern development? Meet MongoDB and SQL terminology. MongoDB stores data as a flexible, intuitive, JSON like objects. Let's map SQL terms directly to MongoDB terms so you feel comfortable. A SQL database is still a database in MongoDB. So SQL table becomes a collection here in MongoDB. SQL row becomes a document in MongoDB. So a column in SQL becomes a field in MongoDB. So instead of heavy SQL joins, we embed data directly or use lookup. Now let's open up a document and examine its internal structure. So here's the anatomy of a document. Here's a real MongoDB document. So here notice three powerful structural features. Primitive values, which are strings, numbers, booleans, and auto-generated unique ID keys. Native arrays, lists like skills, Java, Python, like the list we put enter, live directly inside the document. Embed sub-documents. Objects like location sit right inside without needing a separate table. Everything you need for this record is retrieved in one single read. You might wonder, if we write a JSON in our app, how does MongoDB process it so quickly under the hood? So let's see about JSON versus Bison, which is while developers write and read human friendly JSON, which is JavaScript object notation. The MongoDB database engine stores data as a BJSON, which is binary JSON. Binary JSON is optimized for high speed parsing and space efficiency. So crucially, BSON adds rich data types that standard JSON lacks, like precise data objects, object ID, and high precision numbers. Now that we understand documents, let's establish the real world application project we will build together. So our workshop project that we are going to do is campus seats. To keep our workshop practical, imagine we are building campus seats, which is a real-time campus food delivery application. Our database is campus seats. Our collection is orders. Each document represents a live food order with customer details, order items, and payment status. So, enough of the theory. Let's open our database shell and start executing operations live. So, there are two ways you can use MongoDB. One is the cloud MongoDB Atlas or the local MongoDB Compass. MongoDB Compass is like an application which you download in your own laptop, and it can be used for a local server based database storage. So we are not going to see this, however, but it can be used if this is feasible for you for your pet projects and college level projects. Today we are going to see the cloud based MongoDB Atlas. So here's the website of MongoDB Atlas. Before entering the hands-on workshop, I'd like to show you the sign-in process. So our account is created. We have created a project and we can create a cluster also. So first we have to create a cluster where our cloud providers and regions will be shown. So this is all a cloud-based data storage. So you have to create a cluster, however. You can for high purpose storages you can use this payment based storage, but for us a free storage is enough for now, so we'll s- go with the free storage. And for configurations you can give any name that you like. See, and the provider will be AWS because it is much faster than the Google Cloud or Azure. And for region I choose Mumbai because it is the nearest space where we can have our server in, which will be fast and much feasible for us. Let's create the deployment. So our default current IP address will be stored for local connectivity. So a database user is also created. Before go moving on to the place, you have to copy your database user credentials. Okay, let's copy it here in our notepad. So here's a username and password. If you want, you can download it as an env file and store it securely. So let's choose a connection method. So there are multiple connection methods that are given here, which is like drivers, which moves on to our Node.js and which are like native drivers of MongoDB. You can connect it that way, or you can use MongoDB Compass, which is what we've seen the other time, which is like a MongoDB's UI. And shell is like a command prompt where you can control all the data, manipulate the data using command line interfaces. So MongoDB for VS Code is where you can use your VS Code to control all the data in MongoDB. So Atlas SQL is something where you can connect the SQL tools to Atlas for data analysis and visualization process. So right now we'll go for driver. If you are using Node.js, you can go for Node.js. Or if you're using any other language like Java or Python, you can go for that too. Version must be the latest version for proper connection process. To install your driver, you have to go to your terminal in VS Code and install npm install MongoDB. So this will be your MongoDB's server link, where here in the username you have to copy paste the username that we have already copy pasted here. This will be used for storing application based database. So let's create the cluster. So here the cluster is getting created. We are deploying your current changes. So let's see here. The cluster is still getting built and a sample data set is getting loaded. Here you will be able to see how the connection is happening, how the data size is. So once this is created, we'll be creating our database and the collections. This will take some time to get uh, load our sample data set. Meanwhile, if you want to install MongoDB Compass, please go and search for MongoDB Comp download. So this is completely for your own laptop's server-based purpose. Okay, you can go search for the much similar to the cloud-based MongoDB Atlas. Here, you can do the queries also. The data modeling can be also done, and if you want, you can implement some new connections, like creating a new database for particular applications. This is much easier way for college-based projects, but for application level based, I would suggest cloud-based because this is what the scalable products and high uh, visibility products are being done. Let's try reloading it. is asking for deploy for clusters. Let's go for data explorer. You have to connect it with cluster. So we have the sample data, which is like admin local sample and fix. So the cluster is created and it's getting loaded. You can see all the graphs here, how the computation power is, and if you are like going to store something, it will be shown here. So we'll create a database. I'll name the database as campus eats. Okay. So the collection names will be orders. For time series, you this is used for time series based analysis. If you want, you can use that. So we'll leave this all blank and just create a database. Here in the data, we'll add data, insert document. So you can just remove this. I've already got a stored JSON based data. We'll copy this, we'll paste it here. So this is a JSON format data. Okay. So you have the keys, customer with the data, item with the data. So all the necessary data that we need is being shown here. Insert. So this data is inserted here. Okay. So we talked about documents collections. So I've created a very small database which is called campus seeds, right? So the data collection we have here is ordered name. Others kindly mute. So imagine this database being a food ordering application. So every order that comes into the application is going to become a MongoDB document. So
Sir, I
this
have a doubt.
entire, yes, please. Uh, Doubts we'll move on to the last of the session. First, we'll cover up all the content. Okay.
Okay, sir, thank you.
Thank you. Thank you. So others kindly mute. This entire object is one document. So notice something interesting. I don't have to break this information into multiple tables just to represent this particular orders. Okay. If you are in a relational database, you have to create every tables for each documents and orders that we have to create. Okay. So first we'll understand the document. Let's decode this. Uh, so customer, item, and amount are the fields. The values are the actual data. And MongoDB automatically gives every document an ID. So when we talk about MongoDB, remember this hierarchy: database, collection, and document and fields. MongoDB requires a unique ID field for documents in a standard collection. If you don't provide one, MongoDB generates an object ID. So in case you want to insert another order. So what do? Let's go to the data explorer once. Here we'll put add data. In add data, we'll give insert document. Okay. So Atlas currently provides an insert document flow and supports JSON mode. We'll give our own data. Let's remove this. Let's put so let's put customer and RAM item and let's put burger. Double quote category food amount 200. So as this is a integer value, we won't need to give any quotes. And for quantity 1, as of status, we'll give and for campus, we'll give a different data PIT. Okay. Now we have a particular proper document. So let's just insert this document into our collection. So every document has a object ID as we spoke. Let's see. Our data has been added in the last. So what do you say? This is our first CRUD operations. Okay, CRUD. You have known of CRUD, which is like create, read, update, and delete. So we've seen the create part. We are taking an object, representing an order, and putting it into a collection. And MongoDB has just created a unique ID for this document. Now let's move on to the read part. You created a data, but obviously applications need to retrieve data. That's the R in the CRUD, which is read. If you use Atlas UI query filter interface, demonstrate a simple filter. So let's try this query. So to save these, save name campus order campus leads. So we'll save this aggregation as campus leads. Okay. So here's the aggregate. Now we'll put this aggregate. Maybe. So here in the query, we'll choose only the campus feeds. We are going to choose this particular collection. Sort by, no, let's not do that. Let's search status. So here we've got all the data particularly. So we'll move on to the query once again. So we'll move on to the other part as well. Let's see how the cluster is running. The data is stored. You can see how much data is being stored. It's like 142 MB. You can see the graph, and you can see the graph of the communication also, the computation also. So the sample data set has been successfully loaded. So we'll also see the update part in our CRUD operations. So we'll go on to the documents edit options. Here's a document. We'll use find. Here's a query you can put. This is used for the read operation. Let me put status preparing. So there are two, there are three records where the status are preparing. So we have done the query process. Also, what if the restaurant manager says, show me all the orders above rupees 200? For that, we'll generate another query. GT. So here are all the orders which are above 200. So this Arun and Meena. This record is the orders that have the amount above 200. So what this GT represents is greater than. So this amount field is greater than this 200. So it queries all, it gives all the data, fetches all the details that are about this 200. Okay, so if you put lt, it's less than. So here's all the records which are less than 200. So let's also move on to the update part. Let's reset this. So we have all the records once again. You have to update. You can do the edit document. So you can see all the data and its data types. So let's change this campus. We'll put it as MIT updated. So now the document has been updated. This is how simple it is to use this. And for deleting, uh, now let's say we have to delete this Rahul's order. So and sometimes the data needs to disappear. Maybe the order was cancelled, maybe the record was created accidentally. So that's delete, the final part in the CRUD operations, which is delete. So the document has been deleted. It's over. So this is how you have to insert, create, update, and read or delete records in MongoDB. Also, you can export it as code if you want to, which is obviously in a JSON format. You can take it into Python code. So this is all about the live demo of our MongoDB, and you can create multiple projects if you want to create multiple databases with many applications. Here's the computation, so we can explore the charts if we want to see how our data is functioning inside MongoDB, inside a proper cloud architecture. It is getting loaded. This is how the data can be showed. So, so we have seen the hands-on workshop. Now, let's look at the cloud architecture, which is powering our live demo. Notice that we didn't have to spend 30 minutes installing databases locally. We are just using MongoDB Atlas, which is fully hosted in the cloud. We send commands from our browser shell or terminal through the Atlas Cloud Gateway directly to multi-node distributed cluster. Before we run queries, let's move quickly review the four fundamental database operations. So, every app application in this world in existence relies on CRUD operations, which is create, read, update, and delete. So, create is like you can create insert one record or insert many records. For read, you can find multiple or just find one particular record. For update also, you have the option of updating one record or many records. Similar for deletion. So let's examine how create and read syntax works in detail. So to insert an order, we call db.orders.insert1 and pass our objects containing customer, item, amount, and status. So to fetch data, we run db.orders find customer and the data. Notice the syntax breakdown. DB refers to the current database. Okay, so dot orders targets the collection and find is used for specifying our query filter. Now, how do we update or delete records safely? So, update and delete in action. When updating, we use atomic operators like uh, $set db.orders update one. So with the field name and data as well as set the status, I mean, which is the field and the data you need to change. So using this set modifies only specified fields without replacing the entire document. For removal, db.orders.delete one. So if you put this customer's name, it finds and deletes the matching record. What if we need to complex filtered searches like finding orders above a specific price? So expressive query operators, which is MongoDB provides query operators for conditional filtering, which we have seen, right? Greater than or equal, lesser than or equal to. So in means matching any value in a specified array list. For example, db.orders find that a particular amount and we put greater than 200. So it returns all orders exceeding 200 units. What about searching inside nested objects and array elements? So querying arrays and embedded objects. If a field contains an array like skills, MongoDB, Java, so running db.students find skills MongoDB automatically searches inside the array. To query nested subdocuments, use dot notation enclosed in quotes. So this is how we search for nested objects. So here's for the flexible schema and non-flexible schema. A common mistake beginners make is treating MongoDB as a random junk drawer where every document has completely different field names. That creates chaos in your app. The professional path is designing clear domain models while leveraging MongoDB's flexibility to evolve schema fields smoothly over time without a database downtime. When structuring your data models, should you embed related data or reference it? Let's see that. So here's the data modeling. Embed versus reference. So this is the core design choice. Embed, denormalize. So nest related data inside one document, ideal for one-to-one or one-to-few relationships. Items inside an order provides single read execution speed. Reference, normalize. So store object ID, links pointing to other collections, ideal for one to many or many to many relationships. So here's the example for this: massive product catalogs, which is used to like prevent duplicate blow. What if we need multi-stage analytics, like calculating total sales revenue? The aggregation pipeline. When you need advanced data processing, use the aggregation pipeline. Think of it as an assembly line where data flows through distinct processing stages. So the match is used to filter documents, which is only status is delivered, and group is used to group results and computes totals, which is you can use sum on the amount. For sorting, it orders the calculated results, high performance and scaling up. So without indexes, MongoDB must perform a full collection scan, checking every record. By creating a binary tree index using db.orders.createIndex, and you have to put customer ID 1. Queries jump directly to result in milliseconds. For scaling, MongoDB uses replica switches, primary secondary nodes for availability, and sharding, distributing large collections across multi-server clusters. Let's see how MongoDB compares across broader data ecosystem. So you have to know to choose the right tool. Every tool has a specific purpose. MongoDB is used to build modern web apps, e-commerce, user profiles, and content-based platform. So Redis, which is used in high-speed in-memory caching and session state. Cassandra, it is used for high-velocity IoT-based telemetry. So the data that are received from IoT that can be stored in Cassandra, which can be used for timeline based analysis. So here's the graph based, which is Neo4j, which is used to store complex social networks and graph connections, which are like fraud networks and social graph connections, where multiple data are being stored with many relationships. So MongoDB has also evolved to support modern AI application workloads. So MongoDB with AI era, what's happening? In the modern AI stack, MongoDB functions as a unified platform supporting vector search. It stores vector embeddings alongside standard application documents, allowing modern AI applications to perform semantic search, manage shared memory, and power LLMs efficiently. Now that you have seen the platform capabilities, we can what can you build next? Here are the practical some of the projects idea that you can start building today itself. So e-commerce APIs with dynamic cards. You can try building like a e-commerce application where the API is being connected to the MongoDB. So the dynamic product catalog with all the nested attributes and cart management. And for social media platform, uh, where you can put the user post nested comment arrays and feed updates and the likes all the necessary things that are need to be stored as a data. So for IoT dashboards, tracking device telemetry. So if you are from the electronics side, you can use this IoT based sensor dashboards, um, collect all the data, stream it, and then use that data for live analysis and query purposes. So AI knowledge base, where vector embedding search assistant storing chat history. So like store all the necessary embedding data which can be used for RAG based applications and AI based chatbots. So for student portals, you can use this flexible grade records, course enrollment, and skill tags. Like think about this: your college uses MongoDB, and for every student data, they are going to use MongoDB to store all the data, use for query purposes, and the dashboard analytics. Okay, so for real-time chat app, so this is what I've told about. You can try building an AI chatbot. Okay, um, that in that for database alone, you can use MongoDB, um, where the current data of the user who is chatting with the AI model is being stored in MongoDB. So every time you can go inside the particular application and search for what you have already chatted with the bot. Okay, so let's bring everything together as we conclude the session. So what we have done today, we've started with raw data and tackled RAM memory volatility, explored no SQL documents architecture, and ran live CRUD operations in the cloud, MongoDB Atlas. So don't let your learning stop here itself. So head over to this MongoDB Atlas and just open up your free cluster and start building your next application. Okay, and to see about MongoDB, let's once more look at what we've done. Let's just explore this portal once again, because this portal is so big. I mean, you can do multiple uh, work forces here. You can create multiple projects, and for each project you have a name, have a key and value, and use it as efficiently as possible. Users, you can create multiple users and create roles for them. So for this particular user, I've created it as an organization member, but I'm the organization owner. So applications where you can get the API keys and the connected apps. If you're running real-time applications, then you can connect it with the MongoDB Atlas. So if you're like working as a team together, then you might need to have access for all of your team members, right? So here you'll be able to create a team and add the members and give particular roles for them. Like if some member is authenticated to create the data and update the data, then you can provide the roles only for create and update, but they cannot be deleting or reading the data. And for some users, you can only provide reading the data. They cannot create, cannot update, and cannot delete. So these are some of the advantages that can use Teams for AI model APIs. So inside MongoDB Atlas itself, you have the AI based embeddings and re-ranking models. So for RAG based applications, you have to be using vector search, right? For that, you will be needing the vector embeddings to be stored as a vector database. Here, you can create a particular model and link that model's API into your application. This is one of the particular use case that can be implemented here, as well as you have the usage part where you can calculate all the tokens that are being run in your model, right? So this cannot be used completely free. You might have to pay for some of the models which are like large and which might cost some, right? But absolutely, this has some free quota. Like free usage, you are noted in the green color, and for paid usage, it's noted in the blue color. So try using the free usage, and if you're like gonna use the paid usage, you'll get an invoice and get some cost. You'll have to pay for it. This is not necessary for college level applications, but for enterprise level, startup level applications, you will need to be paying for using it as extensively as possible. So this is the cost explorer. Suppose your database is getting spiked up, like a lot of data is being stored than the uh, level that you are allowing it to store. So this will obviously need to be scaled for extensive usage, right? So in that case, you need to pay for the costs and then use your application as feasible as possible. So other than this, we'll move on to the projects once again. Here's our project that we built on. So clusters. We've seen one particular cluster is running with all the database records and fields being stored as collections. Uh, and here's the computation that is being run, and here's the data that is being stored. So we've added some data, and it's shown that we've added that particular data, and it got some spike, right? We've stored the data of like 150 MB, and if we are like gonna delete it, then it might spike down. All of these can be calculated here. So search and vector search. This is probably used for all the vector-based searches for RAG-based applications and AI-based applications. Okay. Normally, what we will be using is Data Explorer, where all the clusters will be connected with our database and the collections. So this is just 5 records of data. Imagine you want to create multiple records. Okay, so we can like use AI features if you want to. So just need to be giving a prompt here. So create similar records with all the name with multiple data. Let's generate this query for this prompt. Content generated query. Okay, so you cannot be adding data this way. Let's see which the name of the customer who buy the item burger. Let's generate query for this. Okay, we have written a query. First, what it does is there are 5 documents in the collection. Okay, here we have segregated it with the match keyword, which separates all the items with burger, which are stored as burger. Once again, the ID is search for customer. So the documents with burger is being segregated first, and the document and the names of that particular document I mean the customer is searched. So there is ID and customer ID. Once it's searched, we can run. This might be giving a wrong, I guess. Let's remove the what is the item burger. Okay, this seems to be not working because I have not enabled my AI model in my services. So you might try it as well. Like try to enable your AI model and use this um, what do you say, the chat bot that is already available in MongoDB, and this is what MongoDB is all about. Then you can also compare all the tiers. Like there are multiple use cases that can be used here. Like so, you we are students. You are students right now. You can have the free tier right now. You don't have to pay anything. You'll have 512 MB of data. Then all will be limited. But if you're a startup founder or someone who has some enterprise based solutions, then you might want to upgrade it to some powerful um, computing, right? Then you might consider having all these clusters into your MongoDB based thing. And I'd also tell something other than this particular MongoDB itself. Um, so most of you might have heard MERN stack, right? So MERN stack is nothing but the collection of JavaScript-based technologies, which is containing MongoDB, ExpressJS, React, and Node.js. So the React, Node.js, and ExpressJS are of all of front-end and back-end part, where MongoDB is completely the database part. So imagine how famous it should be to use this MongoDB in our application. I mean, how extensively it is used, because it is a non-relational database where flexible data can be stored, not just the table-based data, but also the image-based, all the non-relational database, I would say, in a simple way. So this is how it's particular. So and you also have the resource to learn MongoDB from MongoDB itself. Like they've explained this MERN stack, and look at we just talked about it, right? You don't have to like extensively know about database to start this. You can just, if you're out in the front end and back end full stack level application, you can directly go to MongoDB Atlas and get a cluster, and just get the link, right? Shown you how to connected connect this with the um, local system. So database and network access. So this is one database that we are using. We have all the like database password authentication and username. So I've shown you the link previously, I guess. It gets created while creating the cluster itself. Please make sure to copy that link and this password and the username. So once you've created it, you just have to copy paste that link into your application which is in your local system. So whatever you do it in the local system will gets updated here. So this is all the session is about. So thank you all. If you got any queries, you may ask.
Dear participants, Now the mic is enabled. If you have any questions, you can raise questions. So in the chat also, many of them are asked that questions. You can ask.
I'll look at the chat first, maybe. Um, so Deepa has asked, sir, is it only used for big database applications? No, actually, um, I've showed you the free version, right? You can use it for college level projects and simple pet projects that you are building. But for big database applications and enterprise level applications, you'll have to like pay for it and use the paid version. Is it complex than other DB? No, it's not complex. So there are like MySQL and PostgreSQL, the other types of storage spaces that you can see, right? Those are all relational based databases. But MongoDB is much more flexible. All of the data is being stored as JSON format. All these JSON format are stored as documents, which gets created by an unique ID by the MongoDB itself. So it's the most easiest way of mm, uh, mo- easiest way of database that you can like learn and use for your applications. So Haridarshini has asked, which is better, MongoDB or SQL? It depends on your use case. If your application is going to contain every data as a string value and numerical values only, then you can proceed for SQL, because it is much more flexible for relational data. Like if you have to use multiple joins and relation based data systems, then you might consider going for SQL. But if you're like in idea of storing all, what do you say, images and non-relational data, then you can go more on for the MongoDB. And we have to update the data continuously in the app. Once you connected your cluster with your application, then updating your data in your application itself will create an act in the cluster, and the data will be updated here. Okay, sir. If the same name with two or more. Okay. One person has asked if there is a same name with two or more persons, the object ID is same or not. So the data which is created as a name is just unique data. Like it doesn't have to be like different. You can create it as same. But for each and every document that is stored as a record, unique ID is created. So it's not a problem if there are two or more data like records with same name. So Gomadia has no need to set like primary keys or so. Primary key, foreign key, all of those concepts are in SQL, right? The SQL where you connect other tables as a primary, other table fields as primary key and second like foreign key, that is from the other department. But in MySQL, like NoSQL, it is completely flexible, that you don't have to like relate one data with other data. Everything is done in a query based. So Deepa has asked why we are going for MongoDB than other. That's what it depends on the use case. Okay, some might choose MySQL, which is much more flexible for them. We are choosing MongoDB because we are in a need of storing all the non-relational databases. So, is it flexible compared to MySQL? Others has asked. Yes, of course it is flexible, because consider you are storing some new different format of data. MySQL cannot store any format of data. It has to be a specific format and type of data. But here in MongoDB, it can be of any type, storing in any columns. Okay. So Syed Ali has asked which database to perfectly create cyber security projects. MongoDB can be used for cybersecurity projects, but imagine your data is being like more volatile and more confidential. You need to uh, move on for more confidential purposes of databases. There are some databases. Try exploring it. In MongoDB, it will be secure. Okay, okay. Is it completely? Okay, is it completely free to build small applications? Yes, it is completely free to build small applications, but only 512 MB of data can be stored here. If you need, you can download the MongoDB Compass, which I showed in the local system. Compass is much more better for your local projects. If you have more data and if you're going to store more data, then consider going for Compass, which will use your systems data. Okay. What skills should a fresher learn along with MongoDB to get a developer job? Mubin has asked. So that's what I've told you, Mern stack, right? So learn this Mern stack. You'll learn both front end, back end, as well as the database applications. For database, you'll learn MongoDB. For front end, back end, you'll learn the Express.js, Node.js, and React. So that way, you'll if you are much more better in the CRUD operations and the full stack operations, then you'll get a proper developer job. Yes. So hope I answered most of the questions.
Yes. Okay. So thanks for
Yes,
the
sir. Good
participation.
afternoon, sir.
Okay.
Yes.
Sir, I'm Kavi Brinda, sir.
Okay.
Sir, I have a doubt about developing apps in MongoDB, sir.
Okay.
I think we can use it for back end, sir, or front end, sir. Both can we access, sir.
No, 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 no. Back and front end is a different story. That comes under full stack applications, which is like React and Node.js I've told about, right? That is only for back end and front end applications. For this MongoDB is specifically for storing your data. So if you are connecting this with your full stack application, then all of the data that is being fetched and updated in your full stack application can be stored here. That is what MongoDB is specifically used for.
Okay, sir. Thank you, sir.
Yeah, thank you.
Okay. That's all. So thanks for the participations. So hope you enjoy the session and learn the new things about the MongoDB. So thanks for the participations. So all the participants will receive the e-certificate today, and recording session of this session also will be received today evening. Okay, thanks for the participation. Now, kindly be active in the group. We will be posting a seminar, workshops, and interactive and all. So weekly once